So, the next lesson is trigonomic identities. So, some relationships are always true, regardless of what the angle is. These relations are called identities. An identity is different from an equation. We will practice proving identities. How we do this is very important. First rule, never move things from one side to the other. Never move things from one side to the other. Ever, ever, ever. Don't do that. Next, we are going to work with left side and right side separately and try to get them to equal each other. Step 3, or rule 3. You may use techniques like factoring to help you prove the identity. So, we have some basic identities. One is the Pythagorean theorem, where sine squared theta plus cos squared theta equals 1, which we'll prove in a moment. We have the quotient identity, which is sine theta divided by cos theta will always give you tan theta, regardless of any angle in question. Then we have the reciprocal identities, where cosecant is the reciprocal of sine, secant is the reciprocal of cos, and cotangent is the reciprocal of tangent. Okay. So, part 1. We're going to prove the Pythagorean identity first. Okay. So, for this part, you'll need to remember that trig ratios can be written in terms of x and y. So, for instance, using the triangle in question, I know that if this is my angle in question, then my sine theta will be opposite, which in this case is y, divided by hypotenuse, which in this case is r. So sine theta is technically y over r, whereas again, that's my angle, whereas cosine theta is adjacent, which in this case is my x, divided by my hypotenuse, which is r. Okay, so we're going to use those, that knowledge to help us. Okay, so on the left side, we have tangent theta. I don't know what I can do with that, so I'll leave that for right now. I might come back to the left side. Let's find out. And then on the right side, we have sine theta divided by cos theta. Okay, so let's see. I'm going to use the fact that sine theta is technically y divided by r, and cos theta is technically x over r. Okay, so let's see. So since I'm technically dividing these fractions, I'm going to do the reciprocal, so I know that in my denominator, those values swap. So then I'm essentially doing y divided by r times r divided by x. Using the algebra skills, I know that r divided by r, they cancel out. So I am left with y divided by x, which, going back to my triangle in question, this is my triangle. I know tangent and this is my theta. I know tangent is opposite, which in this case is y. Tangent is y divided by adjacent, which is x. And let's just prove that. So then technically, tangent is y divided by x, and that is what I got. Therefore, left side equals right side. And I'm gonna write a little box. This little box means proven. So I just proved that tangent theta is the same as sine theta divided by cos theta. Okay, so I guess we actually proved the quotient identity first. So now we're going to prove the Pythagorean identity. Sorry about that. Okay, so we're going to prove that Pythagorean identity where the left side is sine squared theta plus cos squared theta is the same thing as the right side of 1. Okay, how would we go about doing this? Okay, well, one way I'm thinking of doing this is I'm still going to use the fact that my sine theta is just like saying y divided by r, as you remember from the unit circle. Sine squared theta is just the same as sine squared, so I'm going to square that. Then cosine theta is the same as x divided by r squared. Just going to highlight so you know where I'm pulling these numbers from, not pulling them out of thin air. Okay. Using your exponent laws, which hopefully you remember, the 2 is applied to everything in the bracket, so we get y squared divided by r squared, which then gives us x squared divided by r squared. Amazing. And since they have the same denominator of r, we can add our numerators normally. So y squared plus x squared divided by r squared. Okay. Since this is the Pythagorean identity, and this is a right angle triangle, so we have y over x, r. Using Pythagorean theorem, we have y squared plus x squared is the same thing as r squared, which, surprise, surprise, that's literally what I have in the numerator, yeah. So then I know that this gives me r squared divided by r squared, which, with the law of exponents, r squared divided by r squared gives me 1, which is what we wanted in our right side. Therefore, left side equals right side. And we just proved that to be correct. Amazing. Then we have some fundamental trig identities. You probably would get this on your test. Read through the tips and tricks. You can do that on your own. But yeah. Okay, let's try the next one. Okay, so let's prove the following identities. So left side, right side. Okay, so let's see. We have on the left side tangent squared plus 1 will give me secant squared x. Okay, so you can either work on the left side or right side, but the main goal is we are trying to get the left side and right side to equal each other. So however you think to do it, by all means. Okay, so we're back. Okay, so when I was looking at this, I was really thinking of my right side. I know that with the reciprocal identities, I know that secant squared is the same thing as 1 over cos. 1 over cos squared. Okay. So not much I can do from here. Let's try working on the left side. So, okay, tangent squared theta, I know is the same thing as sine squared theta divided by cos squared theta plus 1. Since I want to add these, I know I have to multiply my technical fraction by cos squared. Whatever I do to the denominator, I do to the top. So then we are left with sine squared divided by cos squared plus cos squared divided by cos squared. Since they have the same denominator, I can just put them together. So I technically have sine squared plus cos squared all over cos squared. And I know with the Pythagorean identity, which we just found out, that sine squared plus cos squared equals 1. So I know that the numerator equals 1, and then I have 1 over cos squared x, which is exactly what I got on the right side. So therefore, left side equals right side, so proven. Awesome, amazing. Okay, let's try the next one. Okay, so we have 1 minus cos squared equals, actually, sorry, let me do left side, right side. Left side, right side. So on the left side, I have 1 minus cos squared x. On my right side, I have sine x times cos x times tan x. Let's have you try to work on this on your own. So pause this video. Okay, so we're back. Okay, so what I immediately thought of when I saw this is I can turn my tangent x into sine x divided by cos x. So then I know that cos x divided by cos x cancel out. So then I'm left with sine x times sine x, which I know gives me sine squared x. Okay. My left side, technically, this is, on my left side, I do have the Pythagorean identity. But maybe you don't believe that this is the Pythagorean identity. So I know that I know that sine squared x plus cos squared x gives me 1. So I'll replace the 1 with sine squared x plus cos squared x. Then I'm left with cos squared x. And then I know that cos squared minus cos squared cancel each other out. So I'm left with sine squared x, which is what we wanted. Therefore, left side equals right side. So we just proved that. Awesome. Okay. Then we have this one. So on my left side, right side. So my right side, I have sine squared x. On my left side, I have 1 plus cos x times 1 minus cos x. Cool, awesome. Okay, so I'm going to work on the left side first because I already have an idea of what I could do. So I'm going to essentially FOIL everything. So I have 1 times 1, which gives me 1. This is a difference of squares, but maybe you don't believe it. So you could immediately skip to 1 minus cos squared x. But of course, maybe you're not comfortable with your math skills. So I'll still show you. So cos x times 1 gives me, okay, so I have cos x, then we have 1 times negative cos x, which gives me negative cos x, then we have cos x times negative cos x, which gives me negative cos squared x. Cos x and cos x cancel out. So then you're left with 1 minus cos squared x. Okay, so as we had just proven, 1 minus cos squared x is actually part of the Pythagorean identity. So I'll put it over to the side. We'll do yellow, let's do this. Sine squared x plus cos squared x is 1. I could move over, I could isolate for my sine squared x, so I can swap the places. So then I'm left with, actually no, I'll swap those places. Let's move over just the cos squared x. So then you're left with sine squared x is the same thing as 1 minus cos squared x. If you don't do this, I'm completely okay if you don't. I'm just showing those people who may not be comfortable with it. But this just proves that, makes a little bubble. Okay. This just proves that 1 minus cos squared x is the same thing as sine squared x, which is what we wanted. Therefore, left side equals right side, and we just proved that. Awesome. Okay. So we have left side, right side, you have sine x over 1 plus cos x on my right side. I have 1 minus cos x divided by sine x. Okay. Right off the bat, I have no idea where to start when we look at my tips and tricks. Okay, so first tip is always try to change everything to sine or cos. That's already done. Next tip, if you have fractions being added or subtracted, technically they're not really being added or subtracted. Next, use difference of squares. Okay, let me try that. Okay. So technically, I'll work on the left side first. technically I don't have a difference of squares, but I could multiply by the conjugate, which hopefully you remember from rationalizing denominators. We have 1, since this was plus originally, it's going to be minus now. 1 minus cos x. To not change the value, I'm going to multiply the numerator also by 1 over cos x. So then we are left with I'm trying to note. Multiply by conjugate. Cool. Okay. So then we are left with sine x times 1 gives me sine x. Sine x times negative cos x gives me minus sine x cos x. Dividing by difference of squares, I know I'm basically squaring my first term, so 1 times 1 gives me 1. Then cos x times negative cos x is minus, but we're squaring it. And hopefully recall that since these are technically the same terms, but one's plus, one's minus, our middle term cancels out. But of course, you don't believe me, you can always, where was it? We did it. Oh, here. Where they canceled out. Of course, if you don't believe me, totally okay. You can prove it yourself. Then I know that my denominator, my denominator is essentially my Pythagorean identity, which I know that 1 minus cos squared x is the same thing as sine squared x. I see that I can factor out from my numerator. I can factor out sine x. Let's try and do that. So I have sine x. Sine x divided by sine x gives me 1. Sine x cos x divided by sine x gives me minus cos x. This is sine squared x. So then I am left with, okay, I guess it's maybe might be hard for you to see, might not be hard for you to say. So sine x divided by 1 minus cos x. I am going to expand out my sine x, because technically it's sine x times sine x, which means that one of my sine x's disappear. So then I'm left with 1 minus cos x divided by sine x. Let's see my right side. That's what we had. Okay, I think we're done. Therefore, left side equals right side. Proven. Amazing. And then please take the time, grade 11s, to work on these examples. Practice and practice. You're just proving. And I'm going to do a homework check for this on Thursday, if that's okay. Okay. See you Thursday. See you Wednesday. Okay.